Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to start a new topic, which is quadratics. And when we solve quadratics, meaning a second degree equation that has, for example, x and x squared, and possibly a constant term. And when we say we solve it, meaning graphically speaking, uh, a a quadratic equation is represented by a parabola that is either opening up or opening down. Okay? The solution meaning where does it cross the x-axis? So we are going to do that analytically using three methods and graphically, which is only one method. The three methods that are used analytically, the first one is called factoring, which we'll cover today. The second method is called completing the square, which we'll do tomorrow. And then the third lesson would be using the quadratic equation. So, as I said, what are quadratics? Here is a handout. In fact, the first four problems, they already solved. They are factored for us. But we are going to do the remaining. I have 2 pages, so probably I'll do the even numbers. So we'll start with number 6. The highest power is square, so that's a quadratic. It's not cubic if it's 3 or higher that we will learn in Algebra 2. But I want to have them in standard form, meaning the square term first, followed by the single term, which is the linear term, which is power of 1, then the constant. But I have a 5 on the right-hand side. So the first thing you do is you subtract the 5 because you want to bring everything to the left. This is n squared plus 7n plus 10 equals 0. So how do we think about factoring? The first thing we do, number one, you look at the constant term. If the constant term is positive, it means both factors have a positive sign inside, like that. Like that's a positive, that's a positive. That's not positive, 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 positive. So they match. They don't have to be both positive. They may be both negative. How do I tell if so the step number one, I look here, I found positive. So I say that both factors match. I don't say both factors are positive. I say both factors match. I look in the middle term. If it's positive, then both match and both are positive. If the middle number is negative, I say both match and both are negative. Okay? What if this one is negative? If this one is negative, it means they don't match. One of them is positive and the other is negative. But which is which? The bigger number, the sign of the bigger number matches the sign of the linear term, which is n in this case. So if that had been negative, I would say, oh, I'm sorry, if that has been positive, but this is negative, I say they match and they both are negative. If this is negative and this is positive, I say they don't match, but the larger is positive. And if that's negative and that's negative, I say they don't match and the larger is negative. Okay, so these are the first things. So before even starting, I can draw two pairs of parentheses. I write n here and n there, and I write plus and plus. I know all of this. I know all of this. Now, the next step is to say I have two numbers. The product, they give a product of 10, and they get a sum of 7. That's easy. Pretty much everybody of you already got it. But we are saying the 10 can either be 1 and 10. 1 times 10 is 10, but their sum is 11. When the sum is larger than what you want, you bring the numbers closer to each other. If the sum is bigger than what you want, you move them apart from each other. So if I move them close to each other, there is not anything other than 2 and 5 because the 10 is either 1 times 10 or 2 times 5. 2 times 5 or 5 times 2, it doesn't matter. So I know it's 2 and 5 because 2 plus 5 is 7 and 2 times 5 is 10. Very simple. This one was very simple. Equals 0. So either n plus 2 equals 0, in which case I'm going to subtract 2 from both sides and get n equals negative 2, or n plus 5 is 0, and I subtract 5 from both sides and I get n equals negative 5. So the answer is negative 2, negative 5. These are the values that will give me uh, these are the roots. Meaning, if I somehow learn how to draw a parabola, this parabola would cross the x-axis at negative 2 and negative 5. Notice the parabola cannot cross the x-axis more than twice, right? Because that's a quadratic equation, so it crosses only twice. Okay? It can cross, it not cross, but it can have one answer. We can have one answer, not two. Or you may have no answers, but that's a story for a different day. Alrighty, let's move to number 8. Again, I have a 6 on the right, so I'm going to subtract 6 from both sides. So I don't want anything on the right. They are already in standard form. Oh, I have a negative. So now I have two pairs of parentheses, n and n. One is positive, one is negative. I will find two numbers that multiply to 18 and add up to 3, but the bigger is here. Okay? I can have 18 and 1, they add up to 19. That's larger than what I want, so I bring them closer. I can have 9 times 2. Uh, yeah, 9 times. Oh, by the way, when we say the constant is negative, it means one is positive, one and the other is negative, meaning we are subtracting. So instead of saying, I would say 18 minus 1 is 17 and 9 minus 2 is 7. I'm still away. So what else? It's divisible by 3 because 1 plus 8 is 9. So 6 times 3. 6 minus 3 is 3. I got it. The larger is positive, the smaller is negative. Now, when I add them, I get positive 3. When I multiply them, I get negative 18. So either n plus 6 is 0, in which case you are going to subtract 6 and get n equals negative 6, or n minus 3 is 0, in which case you will add 3 to both sides and get n equals 3. So the solution now is negative 6 and positive 3. Moving to the next one. 7r squared. I have to add the 7 to both sides first. So I get 7r squared minus 14r plus 7 equals 0. Here I have a problem. I cannot say two numbers that multiply to 7. Why? Because I have another 7 here. In fact, this problem becomes easy because I can see that all three factors are divisible by 7. So if I divide right and left by 7, the right-hand side stays 0. The left-hand side would be r squared minus twice r plus 1 equals 0. Suppose I didn't see that. I wouldn't say they multiply to 7. They would multiply to 7 times 7. They multiply to 49 and they add to negative 14. And notice, because this is positive, it means both quantities are negative because the middle term is negative and they match. So both are negative. And then I try to find two numbers that multiply to 49 and add to negative 14, which is negative 7 and negative 7. Negative 7. But if I see that I can simplify by 7, I wouldn't need to do any of that. In which case I say I need two numbers that multiply to 1. Well, there's only 1 and 1. And they match 1 and 1. Oops, but the middle is negative. So negative 1 and negative 1. Negative 1 and negative 1 add up to negative 2, but negative 1 times negative 1 is positive 1. So I have two parentheses, r and r, negative and negative, 1 and 1. Here, we have only one solution, not two. In fact, there are two solutions, but they are the same. That's when the parabola is drawn, it touches the x-axis and then go up. So there is only one solution. It's the point where we call the x-axis is tangent to the parabola. Just touches it at one point, which is r equals 1. Okay? So either r minus 1 is 0 or r minus 1 is 0. So r minus 1 equals 0, I will add 1 to both sides and get r equals 1 or r equals 1. So even though I have two answers, but they match, they are 1 and 1. By the way, if I do it here, I will have to have 7r on one and just r on the other because I cannot I cannot get 7r squared divided into any other things other than 7r times r. It's the only way. And then I would say, how do I make 14? If I place a 7 here, would be multiplied by 7r, that will give me 49. No, so the 7 must be here. And the 1 must be there. Uh, yes, so when I multiply these element by element, I get 7r times r is 7r squared. And then I have 7r times negative 1 is negative 7r. But I have negative 7 times r is another negative 7r, which is the negative 14r. And then negative 7 times negative 1 is positive 7. But definitely I would divide by 7 and make the problem easier to begin with. Now, we move to number 12. And in number 12, oh my God, I have too many things. First of all, I have to subtract 11r from both sides. And then I have to add 30 to both sides. So this and this cancel, this and this cancel. I get 5r squared minus 55r plus 150 equals 0. Again, ending with 5, ending in 5, ending in 0, all of them are divisible by 5. So I divide right and left by 5. I get r squared minus 11r plus 30 equals 0. I have r and r matching negative. So minus and minus equals 0. I need two numbers that multiply to 30 and add up to 11. 30, notice they add up because they match. If that was negative, I would say their difference is 11. Okay, so 30 and 1, they add up to 31. Very far away. I need them smaller. So I get 15 and 2, 17, still higher. The 30 is divisible by 3, so 3 and 10, 13, still higher. 30 is not divisible by 4, but it's divisible by 5. 6 times 5. And 6 plus 5 is 11? Yes. So 6 and 5. If r minus 6 equals 0, then r equals 6. And if r minus 5 equals 0, then r is 5. So the answers are 5 and 6, or 6 and 5. Okay? Continuing. I'm going to subtract 3b from both sides. I get b squared plus 2b minus 35. Minus meaning they are subtracted from each other because they are different signs. Uh, Positive 2b, meaning the larger is positive and the smaller is negative. I have 35. I need two numbers. They are different. One and the bigger is positive. So I can say 35 and 1. No, that's 34, too far away. 35 is not divisible by 2 or 3 or 4, but it's divisible by 5. It's 7 times 5. So I put the bigger positive because that's positive and the smaller negative. And 7 minus 5 is 2. Yes, it is 7 and 5. So when I say this equals 0, subtract 7, just save time. So one of the answer is negative 7. When I set this equal to 0, I add 5 to both sides, so b is positive 5. And that's the answer. Moving to the next problem. 6b squared, I have a negative 3, so I'm going to add 3 to both sides. I get 6b squared minus 13b plus 6 equals 0. Oh, now I have two numbers. First of all, both of them match. Why? Because that's positive. And both are negative. So I have something minus times something minus. I don't know the 6b squared. Is it 6b and b or 2b and 3b? I don't know. So we are not going to do that. We are going to say I need two numbers, two negative numbers that multiply to 36 and add to negative 13. So I say, okay, negative 36 minus 1 is negative 37. Very far. So I divide by 2. I say negative 18 and negative 2. The difference is negative 16, still high. 36 is divisible by 3, so negative 12 minus 3 is negative 15. Oh my God, still too high. 36 is divisible by 4. Negative 9 minus 4 is negative 13. Bingo. So negative 9 and negative 4. How do I make 9 and 4? For example, if I make this is 3b and this is 2b, in order to make that 9, I multiply it by 3. And in order to make that 4, I multiply it by 2. Now, do you see? 3b times negative 3 is negative 9. And negative 2 times 2b is negative 4b. They add up to negative 13. 3b times 2b is 6b squared. And negative 2 times negative 3 is positive 6 equals 0. So if this is equal 0, I add 2 to both sides. 3b is 2. I divide by 3, so b is 2/3. Add 3 to both sides, I get 2b is 3. I divide by 2, I get 3/2. These are the two answers. Uh, let's move to number 18. I have minus 4 minus 4. So I get 35k squared minus 22k plus 3 equals 0. Positive meaning they match. Negative meaning both are negative. So I have two parentheses with a negative sign in the middle of each. But the product 3 times 35, that's 105. Okay, so how do I do that? I say 105, negative 105 minus 1 is negative 106, very far away. 105 is not divisible by 2, but it's divisible by 3. I already know it's 35 times 3. So if I say negative 35 minus 3, I get negative 38. Still large. This is divisible by 5. Okay? It's negative 21 times 5. So when I subtract this, I get negative 26. Still smaller. This is divisible by 7. Divided by 7 is negative 15. And I'm sorry, we said 7 and, yeah, 7 and 15. When you subtract, you get negative 22. Bingo. So, okay, one term gets me 7, so that must be 7k, right? And that must be 1. So when I multiply it, I get the negative 7. If this is 7, then this is 5k, right? 7 times 5 is 35. And the other one, if this is a 5, the other has to be 3. So when I multiply this, I get the negative 15. And when I multiply the outer, I get the negative 7. So k is 3/7 by adding 3 to both sides and then dividing by 7, or 1/5. I add 1, I get 5k equals 1. I divide by 5, and these are the two answers, and it was tough. But as you learn how to factor numbers, this is very important. I also showed you in a video how to recognize if a number is divisible by 2 or 3 or 4 or 5 or 6 or 7 or 8, so on. Okay, now I'm going to move both of them to the left-hand side by subtracting 27b and adding 18. I get 10b squared minus 27b plus 18 equals 0. Now, I need two numbers that multiply to 180, and both are negative, and they add up to negative 27. Well, of course, negative 180 minus 1 is negative 181. That's very far. But it's divisible by 2. So if I say negative 90 minus 2 is negative 92, still far away. Dividing by 3, negative 60, and negative 3 would give me negative 63, still too high. That's divisible by 4. Negative 45 and negative 4 is still too high. Divisible by 5. Negative 36 and negative 5 is still very far. Divided by 9 after that, right? 9 would give me 20, so negative 20 minus 9 is negative 29. Oh, we are so close. So divide by 10. Maybe. I don't know. Dividing by 10 would give me negative 18 minus 10 is negative 28, not 27. So try 12, because that's also divisible by 12. You get negative 15, negative 12, bingo, negative 27. So how do I make 15 and 12? Notice, we divided that by 12, we got 15, right? So, and how did we get the 180? It was 10 times 18. Okay, so one of these should be 5 and the other is 2. I don't have a 10 here, right? If I was here, so this cannot be 10 and 1 because I don't have 10 times anything will give me neither 15 nor 12. So that must be 5b and 2b. That's the only chance, right? 5 cannot make 12, but it can make 15 when it's multiplied by 3. The 2 cannot make 15, but it can make 12 by multiplying it by 6. So now I have 10b squared, I have positive 18, and then I have negative 12b and negative 15b. So the answer is b is 6/5 or 3/2. And you can see that it can become really tough. And maybe if it's that hard, we may try to do those using completing the squares. And if completing the squares is tough, we use the quadratic equation that would give me the answer no matter how complicated it is. Okay, last one. I have a 3 and a negative 7, so I'm going to subtract 3 and add 7a to both sides. So this is 15a squared. 7a minus 3a is positive 4a. and -3 equals 0. These multiply to -45, but because it's negative, I have two numbers. One of them is positive and the other is negative, but the bigger is positive. So if I say 45 is 45, the other one would be -1 because the sign is the sign is opposite. And when I add them up, I get 44. That's way far from what I want. 45 is not divisible by 2, but it's divisible by 3. It's 15 and -3. The difference is 12, still too far. 45, we know it's also divisible by 5. It gives me 9 and -5. Oh, that's it. Okay? So 9 and -5. How do I get 9 and 5? 5 by itself has to come from the 15, right? So one of them is 5a multiplied by -1 because that's where I get the -5. The other would be +3 and +3a because that would give me the +9a. Now, 5a times 3a is 15a squared. 3 times -1 is -3. -5 plus 9 is +4. So I get a is -3/5 or a is 1/3. Just here you subtract 3 and then you divide by 5. Here you add 1 and you divide by 3. And that's it. As I said, the last 2 or 3 were tricky, but if you learn how to factor numbers, factoring is very important for that reason. The method is called solving quadratics using factoring. So here you have it. Okay, so that is the first method we use to solve quadratics. Tomorrow we are going to see how we complete the squares. I will find another sheet and then we will go over that. And until then, I wish you all the best. Thanks for your time. See you tomorrow.